Okay, today we're going to be going through Kruskal's algorithm, however you want to pronounce that. Yeah, it ends up forming a minimal spanning tree that avoids adding edges if it forms a cycle. That's definitely a key point here. And it also connects v minus 1 edges, so we stop adding the edges when we reach v minus 1 for the vertices. So in this case, if we just start looking at the graph, and luckily all these vertices are ordered. So let's just do a little count. We've got 0, 1, 2, 3, 4, 5, 6, 7, and 8. So if we do a count on these, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 vertices, and using this formula here, 9 minus 1 is equal to 8. So we want to stop adding edges when we reach 8. This will make sense as we continue on with this algorithm. Okay, so yeah, as I said, it helps that these vertices are ordered, but that doesn't necessarily make a difference in how Kruskal's algorithm works. So we kind of just have it, taking a look at this graph here, just using our eyes, we want to try and find the smallest edge weight, and we want to start with that. So we have the edge weight of 3, which connects like 2 and 6 together. Cool. And then the next smallest edge weight I can see should be 6. It's this 6 here. So that connects 3 and 5 together. So following on, our next smallest edge weight looks like it's this 7 over here. So 7 connects 3 and 4. Let's just put a little line here. And then we have, after this, we have 8. So we need to be careful here, because if you remember this rule over here, we don't want to add any weight, that any edge that forms a cycle. So if we add, we've already added 3 and 5 here, and then we've added 3 and 4 here. So if we add this this edge here, it will create this cycle, so we don't want to do that. Okay, so the next smallest value aside from this one is this 8 over here. So 8, which is formed from vertices 0 and 3. And this is a undirected graph, so it doesn't really matter what order you put these numbers in. So if you can see, we've got 1, 2, 3, 4 kind of sections here. And remember, we want to stop when we get to 8, so let's just do a little 5, 6, 7, 8. Okay, so moving on from 8, looks like we have this 9 over here. So we're going to go from 9. And this connects vertices 5 and 8 together. Moving on, looks like we have this 10. So we can add this 10, and that is formed from 1 and 2. And then we have this 11 here as well. So we can add this 11, which connects 2 and 3 together. I just want to draw some arrows to kind of highlight the direction we've gone actually, just so we can keep track. So we've gone this way. If you kind of look at here, we've got 2 to 6, and then we've also got 3 to 5. And then we've got 3 to 4. And then we've got 0 to 3. Let's remove these arrows. And then we've got 5 to 8 as well, going this way. And then 1 to 2. So yeah, 1 to 2 here. And then we've also got 2 to 3. So we've been pretty careful and doesn't look like we've added any cycles. I'm just doing a little sanity check. So we're up to the edge weight of 11. Looks like 12 is the last one. But 12 looks like it'll create a cycle. So we're going to move on to 13. So 13 connects, 8 and 7 together. So I believe this is the correct answer. If not, I'll have to record this again, which will be annoying. So the particular question I've been asked is to list all the, the edges. So our answer would be for, I'm doing question A, it would be something like, 2, 6, 3, 5, ... until we have 8, 7. And that's kind of how you answer the question. Another question that was part of this is, question was something like, what cycles did you avoid? And then like, please list them, blah, 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 blah. So if you remember, I spoke about this one that we wanted to add, that this 8 that was actually a fairly low number we couldn't add. So that would be a cycle that goes from 3 to 5 to 4 back to 3. And then I also didn't add this 12 here. So that would be something like 2 to 3. Actually, I'll put a dash. These should all be dashes here. So 2 to 3 to 0. I just should have done the dash. To 2.